In this video, we are going to discuss about transformer coupled Class C amplifier. So basically, we know that in the direct coupled Class C amplifier, the efficiency is 25% because the load resistance is directly connected to the output of the amplifier. That is the ICQ, which is passes to the resistance. Due to that, there is a lot of wastage of power. So here we are going to solve this problem by connecting a suitable transformer for coupling the load to the amplifier stages. So here the primary winding of the transformer has a low resistance, therefore the power absorbed by the winding is negligible as compared to the resistive load. So let us draw the first the circuit diagram of the transformer coupled Class C amplifier. So RE is a emitter resistance and C is a, so the C represent the bypass capacitance and R1 and R2 is biasing resistance. So here I have connected so instead of RC I have connected a transformer, which is the input of the transformer is RL, resistance of the transformer is RL bar and the output is RL, and I have given a DC power supply. So I can write this RL bar is equal to V1 by I1, and similar way I can write this RL is equal to V2 by I2. So we know that V1 by I1 V1 by V2 is equal to N1 by N2, that is equal to I2 by I1. So I can write V1 is equal to V1 is a primary voltage, that is equal to N1 N2 into V2. Similar way I can write I1 is equal to N2 by N1 into I2. So what we need the value of V1 by I1. So this is your first equation and this is your second equation. So you divide the first equation by second equation, so you will get V1 by I1 is equal to N1 by N2 into V2 divided by N2 by N1 into I2. So what is V1 by I1? V1 by I1 is RL bar that is equal to N1 by N2 the whole square into RL. So where N1 and N2 is, N1 is nothing but the primary turns and N2 is nothing but a secondary turn. So I can write here RL bar is equal to N square into RL, where N is nothing but 1 by N, that is equal to A, okay, or I can write it as N1 by N2. So therefore I can write RL bar is equal to A square RL. So normally we are using a step down transformer, therefore the A value is much higher than the unity, right? So this value is less. If this value is less means A is greater. Therefore RL bar is always greater than RL. So you can see the load resistance I have reduced, right? So let us draw the curve, IC versus VCE. So since the value of RC is equal to 0, right, the ICQ value is increasing, goes to infinity. So therefore the VCE value, VCQ value is equal to VCC. So the Q point will locate here, and the DC load line, this is your DC load line. Okay, since the ICQ value is increasing. In similar way, if since this value is VCC, the Q point value is VCC, and we know that the input the AC load line is from which will towards this point, and this value is nothing but 2 VCC, right? And this is nothing but VCC divided by RL bar. So this is AC load line. So I can write PDC. PDC is equal to VCC into ICQ, and PAC. PAC is equal to VRMS into IRMS. So this is nothing but VM by root 2 into IM by root 2. So this is nothing but VM IM divided by 2. So since so VM IM divided by 2, so this is nothing but your VM. So this is nothing but 2 VM, and likewise I can write this is 2 IM. So I can write VM as 2 VM into 2 IM divided by 4 into 2. So this I can write it as 2 VM into 2 IM divided by 8. So 2 VM I can write it as Vmax minus Vmin. So this is your Vmax and this is your Vmin. So 2 Vmax I can write it as Vmax minus Vmin. Similarly 2 IM I can write it as Imax minus Imin divided by 8. This I minimum value is 0 and V minimum value is also 0. So you substitute, you will get Vmax Imax divided by 8, where Vmax value is nothing but 2 VCC. This is your Vmax value, and Imax value is nothing but 2 ICQ. By 8. So you substitute Efficiency is nothing but PAC divided by PDC into 100, where PAC nothing but VCC ICQ divided by 2 by VCC into ICQ into 100. So these two get cancelled out and you will get 1 by 2 into 100. That is nothing but 50%. So the efficiency of transformer coupled class A amplifier is 50%. So let us discuss the advantage of transformer coupled amplifier. First advantage is, since we are not the efficiency is improved, right, compared to direct coupled. Efficiency is high. And the second one is impedance matching. Because we are using a transformer, impedance matching is possible. So third point is wastage of power is eradicated. So next one is disadvantage. So the first disadvantage is the circuit is bulky, because we have employed a transformer, and therefore it is costly. The circuit design is complex, right? Next, the frequency response of the circuit is better than the direct couple, and it is less than the class B operation. So you can see this VCE VCQ of AC is nothing but VCQ of DC plus ICQ by R L bar. So this value is already, we know this is VCC, and this value also is VCC. Therefore this point causes 2 VCs.